finally it gives us electricity power. This is a digestion process, anaerobic digestion process. This is a flow diagram, how it works, the total plant, a biogas plant. Degradable waste, then degradable waste handling platform, then segregation chamber, then mixing chamber, pre-digestion chamber, then anaerobic digester, slurry pits, solid pits to digested slurry, recycle water, and from anaerobic digester it goes to biogas plant. These are the biodegradable waste management process in detail. Now economy, how it works. Supply of gas in our plant is 85 cubic per day in 2 cycles. We generate electricity 80 or 90 units per day. Our installation cost of this project is 18.5 lakhs. Operation cost is very nominal. But by product we are getting organizing fertilizer, that is 1000 kgs per day. These are real photographs of the plant. Thank you.
Can all of you see strays on my head? I'm having a problem, you know. I have got one last question to answer and I have got only 5 minutes and it's going to take 20 minutes to answer. What I'm supposed to do? It's my problem, kindly help me out. It's an humble request to all the speakers. Kindly please stick to the time because you know we are running late by at least 15 to 20 minutes and the sun is getting hot on our head. It will be difficult for everybody to maintain the same pleasure. So it's my honest request and humble request. May I request Dr. Upendra Patel from MS University. He is going to talk about vermi filtration and the same case study was talked about by Shashi sir when he was giving his keynote address. Dr. Upendra Patel.
It has been quite a since you have been listening to the speakers and that's why I'll not make it very long. Certainly some of the things which I must mention before I start, which I liked was the speech by Shashi Bhai, integrating technology and spirituality, which is personally I like the most. So I'll start the first slide is again coming with the same message of recycling. And you can see all of you must have seen students and those who are connected with engineering. This is a simple natural ecosystem which shows that there is no waste. Only waste is the heat. Only thing which is coming out from this whole system is just heat. The food comes from the waste from the previous eater, you know, so it is like everything is cycle in this. So this is what we have. We have only one source of energy coming in and all the nutrients are recycled within. And now see how we are doing, how we are processing our day-to-day waste. This is what we have. We have our resources with us. There is good quality water in river or in ponds or lakes and other minerals. We use these resources. We add some processes, some energy to this, and we make the products out of it. And in process, what we do is we generate this. At some stage everywhere, whether at the time of generation of the product or at the time of use of product, we generate this thing. And then what we do with this is what we have. It dumps somewhere. So the question is, now if you compare this with the natural ecosystem, what is happening is, we are not going back. We are not going back to the zero again. So unless and until we do this, or do this, we are not going to complete the cycle, and that's why we do not have right to survive. In fact, let me tell you that environmental protection is not required by environment. It is required by us because we want to survive. not the environment. So it is basically the same in the same line. This is how we are doing our wastewater management, domestic wastewater management. We have all the wastewater coming from various areas, and we are then conveying it to some other remote place. My previous speakers have already made very clear about it. It goes to some other source of body and mostly untreated. It is discharged there. So this is what the problem is. This is our common conventional something which has we have been very impressed with Western countries, and that's why we have borrowed this system from them. This is the system conventionally going on in our country also, that we collect wastewater from all the places and then convey to some place. I do not have any problem with this. Only two things which I want to mention are those. One is that I am collecting water from all the places and conveying at some place where it may not be required. So I am taking water from my area to some other place. And along with that, what I am doing is, very importantly, the nutrients. The nutrients in domestic waste, which is coming out from excreta and urine in form of nitrogen and phosphorus. We are sitting in GSFC. These people are manufacturing fertilizers, and I may not be correct, but probably in last decade or so, phosphatic fertilizer prices have gone up 4 times. You can imagine. And the problem with phosphorus is a long topic. We'll talk somewhere whenever we have chances. But anything can be recycled, but not phosphorus. And that's why unless and until we preserve that, it is not going to be a sustainable solution. And what do we do with this wastewater once we collect it from various places? This is the data given by CPCB. You can see out of total number of STPs in India, almost more than 51% are not functioning. And that means that most of the wastewater which we are collecting from the cities are disposed untreated. So my water is lost from the city and nutrients are lost. This is another figure, just says that almost 30,000 mld of wastewater goes untreated. This is what I promote, which is a decentralized wastewater treatment, where what we can do is we can have small treatment plants at various places. Maybe it can be used within the city as well as in the new developing areas where there are no sewage connections, what we heard earlier also. It can also serve, very importantly, rural areas, because so far in rural areas there are no systematic ways to treat wastewater. It is all thrown into the pond or wherever such places, low-lying areas. These are some of the options of low-cost decentralized wastewater system. What I'm going to talk about is vermifiltration. It's a very simple technique, nothing much technically in it, but what is great about it is the simplicity with which it can be made and operated. The last point I would just emphasize, it is, in fact, it is made up of earthworms, mainly in a bed of soil and vermicompost. And then what you can achieve is about 90% of BOD or 80-90% of COD removal. Very huge removal without much inputs. This is, pardon me if it is not very clear, but what I mean to show in this case is that it's a layer of different material which are filled in it, and the top layer is the key, where a lot of earthworms are there and their habitat for them is created in that. And over this bed, the top bed, we are spraying wastewater. These are some of the earthworm species which are very widely found, occurring various places in our country, where almost so many places in the world also. And those who are good for vermicomposting are also good for vermifiltration. So you do not buy anything which is something very special. It is very easily available. Some of these you might have seen in your gardens, backyard, wherever. The important thing is, how does it work? There are two mechanisms by which it works. As Mr. Munirawal earlier said, that it has got probably, the soil has got almost 100 times more bacteria than equivalent amount of domestic sewage or something. So a lot of bacteria are there in the soil. So microbial degradation is going to occur in the soil, which is in the top layer. And there are enzymes generated by earthworms, which are going to degrade the small colloidal solids. So there is no pre-treatment required. You can just simply take whole wastewater into it. Earthworms also granulate clay particles. You must have seen their excreta of earthworms, which is granular in nature, and that's why it increases the surface area. Again, it increases, so surface area increases, more sites for reaction, and the rate of removal also increases very well. Then the question may be this: what will happen to the bacteria? Because bacteria will keep on growing in it, and it will ultimately taste. Probably you can use it as a poultry feed, or you can donate to somebody else, or whatever. I mean, they are not the problems. You can at least leave it, you can sell it, you can leave it in your soil. It is definitely a commodity. So out of waste, we are generating something which is good for the nature. So and with not much inputs required in terms of energy or any skill, this thing. Now what we do with the treated water, when it comes out, it has got very low toxicity because earthworms survive in that. Also their body is like a biofilter, so a lot of heavy metals or some other such compounds can be absorbed on their body. So wastewater does not contain them. Nutrients are not destroyed in this process, and that's why most of them are available to us in treated water. And as I said, the excess biomass in form of earthworm can be sold, or it can be used for this. So this is just a simple mathematics. If you have a family of 5 persons or 4 persons, maybe a small place is required where you can treat so this much of about 600 to 700 liters of wastewater which is generated from that family, and you can achieve about 90% BOD removal, and the same water can be reused for flushing or in gardening within that premises itself. This is the study. I have been working with the scientist Dr. Rajiv Sinha, who has been was the earlier professor at Griffith University, Australia, and this picture I have taken from one of his papers, and you can see the kind of treatment that can be achieved with this system. I also developed similar plant for a girls' hostel where I was earlier working in Charlotte University of Science and Technology. What we are getting continuously, it has been almost 9 months old, and it has been working since then without any problem. The effluent turbidity is less than 10, and effluent COD is about 35 to 50. It's a small bed, about 3.5 to 4 meter, and we are using it for more. You can also observe this. There is a lot of grass and leaves on this. So in addition to treating wastewater, I am also using this as a vermicomposting bed also, because earthworms are there. So my biomass also, I mean, that is the loans and all the things, that also is being utilized here. So it is a win-win situation both the ways, not only treating wastewater, also some of my green biomass also. This is another plant that I developed at, it's in a preliminary stage. This is for a dairy. The wastewater is definitely having high COD and BOD. And the first stage treatment is showing this much of removal. What I am trying to do is to have another stage to reduce this further, and again the aim is to use it for the irrigation within the plant. So it has been going on, and we'll have that results. There is one more project coming up which we are taking up. It is near Nariyad, in a village where we are going to treat about 15,000 liters per hour of domestic sewage generated in that village itself, and we'll use this treated sewage by vermifiltration in a separate plot for irrigation only. So irrigation in that plot will come only through the treated domestic wastewater. There will not be any other nutrients addition. There is no fertilizers also. Only nutrients which are coming from the treated water will be used, and we are trying to then compare the yield of crop with the conventionally irrigated field. So this is what we have. It's a simple technology, and very well utilized. So probably what I would like to say is that if it is promoted for decentralized wastewater treatments, then certainly it can relieve a lot of burden of municipal corporation as well as other companies. Thank you.
Thank you, Dr. Upendra Patel, for a very simple and lucid lecture. Something different has been done this time by the committee who has been organizing this program. A new concept has been developed to create a second lineup who are going to be the responsible citizen. There were 8 presentations which were taken from the different colleges all around Baroda. All of them has given the presentation which was selected by the respective college. And from them, the judges and the committee has selected one particular person whose presentation was considered to be one of the best in all of them. But mind well, it was a very difficult task for all the judges to differentiate between first and all 8. So let me first of all acclaim and recognize all the person who has participated in the presentation and give them a round of applause. It was a wonderful thing, and I'm really telling you it was very difficult for the judges to find out who was first and who was 8. And a great work of society that second line was created, which is one of the very important things. And these few lines which I'm going to talk about is basically to all the students who have participated, and for specifically the person who is going to take a space on the stage with all these learned speakers, Mr. Akshay Rami. He is going to talk about it. And the few lines for all the students and Akshay is, जो धरती से अंबर को जोड़े उसका नाम मोहब्बत है, जो धरती को अंबर से जोड़े उसका नाम मोहब्बत है, जो शीशे से पत्थर को तोड़े उसका नाम भी मोहब्बत है, कतरा कतरा जाता है हर उम्र, वापस दरिया को जो मोड़ दे उसका नाम मोहब्बत है, जो वेस्ट वाटर को रिसाइकल करे ना उसका नाम भी मोहब्बत है. अक्षय प्लीज.
Good afternoon, senior engineers and my friends. I will be talking about recycling and reuse of sewage water. Less than 1% of fresh water is available for the people on the earth. In most of the countries, human population is growing while fresh water availability is reducing. Demand of water resources for household, agriculture, industrial and commercial purposes are increasing. So to maintain and increase the amount of fresh water, we have to recycle and reuse the wastewater. In India, the main problem of recycled wastewater is social acceptance. Due to people are not ready to accept the ideas of recycling and reuse the wastewater. In water management, why we need to recycle and reuse the wastewater? The main reasons are increase in human population, increase in per capita consumption, depletion of underground water level, high level population in surface water, and irritating nature of rain. In water management, it is convenient as well as economical to process and reuse wastewater at inception level. We are saving on convenience infrastructure and maintenance cost. I will be talking about domestic wastewater. Detailed consumption of water on per capita basis, drinking and cooking purpose 10 liter, bathroom 50 liter, washing 20 liter, toilet 50 liter and gardening 20 liter. So total consumption of water on per capita is 150 liter. Bathroom wastewater can be recycled and reused for toilet flushing and gardening. Now I am talking about case study. As a part of our study, we have studied the case of SEVATIRTH for solution of wastewater disposal. This is the site plan of SEVATIRTH, and the main problems of SEVATIRTH. SEVATIRTH is outside the corporation limit, hence water supply and drainage network is not available. And the second problem is the water in the aquifer has more than 5,000 TDS and it's not potable. So to maintain and so they solve this problem by rainwater harvesting. They collect rainwater in 4 lakh liters underground water storage tank and use for only drinking and cooking purpose. Then SEVATIRTH soil strata is black cotton, hence wastewater is not absorbed in the soft pit. At present, wastewater is disposed in the open ground where new residential buildings are coming up. So this is the main problem. Now daily requirement of water at SEVATIRTH. Total number of occupants is 150. Drinking water requirement is 1,500 liter per day. Then bathroom water requirement is 7,500 liter per day. Toilet water requirement is 7,500 liter per day. Washing requirement is 3,000 liter per day. And gardening water requirement is 3,000 liter per day. So total requirement of water is 22,500 liter per day. Then domestic wastewater main two parts is sewage and sewage. It is processed to proposed to process sewage and sewage water separately. Sewage will be processed by anaerobic digester, which is already constructed at Kakadia and SEVATIRTH. But sewage will be processed by us. These are main buildings of SEVATIRTH, which is the source of wastewater we collected. These are the we have studied the case, and these are the main buildings outsourced. And this one is a collection of sampling. These are the results of wastewater and freshwater of SEVATIRTH. Now, following process have been studied by us. First one is sand filter, second one is activated carbon, lime alum and hydrogen peroxide. First, sand filtration method. We filtered wastewater by inverse flow, and that we studied the details of it. And sand filters remove suspended solids very well. And lime alum. Lime alum is used as a precipitant, particularly in wastewater. Lime alum help in grit separation, oil and grease removal. But lime alum not remove color, odor and turbidity very well. So then hydrogen peroxide method. Hydrogen peroxide is 6% weight per volume. Then we add hydrogen 5 ml in sample of 50 ml wastewater and recycle it. Then H2O2 removes odor, color and turbidity very well. Then last one is activated carbon filter method. In the market, we get 4 types of activated carbon. First is 4-diactivated carbon, second 3.5-diactivated carbon, third one is 3-diactivated carbon, and fourth one is coconut type activated carbon. Then we filtered by coconut type activated carbon filter, and the flow of it is 5.6 liter per hour. Activated carbon removes organic chemicals, pesticides, radon gas, hydrogen sulfide, mercury, and mainly odor, color, turbidity and taste. Now, the results and concludes. Results of treated bathroom wastewater is the main parameters BOD and COD. The last one is irrigation standard, which is the criteria, and middle three are the treated wastewater, and first one is the untreated water. Now we see that the treated water is in the criteria of irrigation standard. In pH and turbidity is 2, but in TDS is not in irrigation standard. So we cannot use as irrigation purpose and gardening purpose. We can only use for gardening, only use for toilet flushing. Recommended process of recycle wastewater is starting from fresh water using bathroom, then collection tank of bathroom wastewater, then treat by sand filter and activated carbon, and treated water is used for toilet flushing. Then it was used as an anaerobic digester.